All right. Good morning, everybody. We're ready to get started here. Um, I'm still kind of catching my place here. I had to run around this morning. I had to take the dog into the vet this morning, so I didn't have quite as much time as I usually do to sit down and figure out everything I'm supposed to talk about. But I might have to pause a couple times to kind of catch my place here. In fact, let me open my other book up. Right. This is the one we're looking for. So, like I say, I may have to pause occasionally this morning to just catch my place, since I didn't have as much time to sort of prepare. But we can kind of move forward. So, what I want to point out to you is notice that the last couple chapters did not have a project component to it. Right, where we've been having these project discussions inside of Canvas, and you go in there and you actually are earning points towards your project, which is really good that you get those in, because those points are sort of, they will play a large role in your overall grade, and they're kind of easier to get. As long as you did a legitimate job in answering those questions, you tend to get full credit, right? Not if you just go in and write junk or something, but if you go in there and it looks like you did an honest effort to do the assignment, then you'll get full credit. So basically what I want you to do is go in and you calculate some confidence intervals for your data, right? You can calculate confidence intervals for proportions, and you can calculate confidence intervals for the mean. So any problem that you have that has a mean or a proportion, calculate the confidence interval and talk about it. Okay, so it's pretty straightforward, considering that StatCrunch is going to do that for you. You have that coming up, due November 30th, which, when is November 30th? That's a little more than a week from today. So we'll see each other again, right? I know the holiday is going to kind of mess things up, but let's take a look specifically about when that's going to be. November 30th is a week from tomorrow. Okay, so you have some time, but it's coming. So I just want to point that out, because the last couple of chapters, we didn't have these discussions, right? Because I just don't think it makes sense for those chapters to really be able to. It's not intuitive. It's a little more challenging, and probably there's not a whole lot you can say, because you didn't do repeated samples you took one sample. You didn't have repeated samples, so some of the stuff doesn't quite make as much sense in terms of the project. It's still really good to know in order to understand all the statistics that comes after it in the course, but I couldn't think of a good way to have you use your own project to do that. So chapters 7 and 8 did not have a project component discussion at the end, but I just want to make sure everyone realizes that chapter 9 we do. I'm not going to be able to extend that due date, so make sure that you're getting that done. Okay, those of you who are still showing up to the meetings, that's great. Those of you who are watching the meetings at a later date, that's okay. Those of you who are not watching the meetings obviously won't hear what I have to say. But and some of those people may be asking for an extension because they go, "Oh, I didn't realize there was a thing due." Just be aware. Right? Be aware that it's there. That's an easy 10 points. Go in and have StatCrunch calculate some confidence intervals for you, put them down, and sort of then you know how to do the confidence intervals for your project, right? When it comes to the project, hopefully you'll put in a little more thought, when you're sort of putting the whole project together, but you'll know how to do that skill of calculating a confidence interval for a proportion and confidence interval for a mean, which by all means you should be using in your project. Okay, right? It's not enough to go, "Oh, well, I did do one confidence interval." Well, probably you want to do more than that, right? Just sort of a heads up about how the project works. You're also going to have you're going to have two things at the end of chapter 10. Right? You've got the hypothesis testing version, which again, you just learn hypothesis testing and then you're going to apply it to your project. But then we have the actual project due, right? The project due, and then your project's due, right? So it's not that far off It's not that far off where things kind of come to an end here. And again, those due dates, I'm supposed to be strict with those due dates. The school has policies. It's not my policy as a professor about, oh, okay, you turned your stuff in late. That's okay. No big deal. Because then we open ourselves up to accusations where people say, well, why does he let some people turn it in late, but I had to get mine in on time? And that's a fair argument, right? We want to make sure that we're treating people fairly, and that the people who are doing their work the right way are, they're being rewarded for doing things the right way. So make sure you have all your stuff completed and turned in on time, and you're all ready to go. I think it would be great to give everyone a passing grade in the class. That would be awesome. That never happens, but it would be great. So try to get your stuff in, okay? Not to say that getting it in guarantees a passing grade, but if you don't get it in, you won't get a passing grade, is how it works, right? So I do have office hours. My office hours are going to be interrupted today. Today's just kind of a weird day for me. So that's, if you show up at certain times, I will not have, it's kind of a little unpredictable today, but I will not be able to help at certain times in office hours. So if you show up and the office hours aren't open, meet with me, and I'll try to meet with you at a different time. I'll try to either meet with you in another office hour, or I will try to set up an appointment with you to meet that are outside of office hours, or something like that. But I don't want anyone doing bad because my weird day and having to cancel part of my office hours would interfere with you doing well in the class. I'm starting to see more students coming to office hours, and that is what should be happening, right? If you're at all concerned, or you have questions, or you're not quite sure about the project, come see me in office hours. Let's have a discussion about it, and I can walk you through any questions that you have so that you can make sure that when you do turn in your project, you're turning in a quality work, right? There's more and more. This has always been the case. Humans have always been terrible procrastinators, but it is something that, they're showing is growing. Because we have this technology all the time. There's research that shows us, since we have technology that always reminds us when stuff has to be done by, there's a certain mindset people get into, that thinking, okay, I'll do it right before that. I can wait on this, and I'll do it right before it's due. But just as there's also been research that shows the number one thing holding back human beings is procrastination, right? The truth is, and I can tell you this as someone who's been teaching full-time for 12 years. I've taught, that means I've taught, if I'm teaching 5 to 12 classes. So 12 about 12 classes a year for 12 years. I'm approaching 150 classes that I've taught. I can tell you without a doubt, the people who do their work ahead of times do better work, right? The people who are getting it done right before it's due, sure, if you see the goal as, I have to get my assignment in on time, then your work is probably not very good, right? If you see it as, oh, it's due Friday, I'm going to try to get it all due by Wednesday, and then if I have a problem, I can work on it later. Those people do way, way better work, right? I mean, I could probably, if I go through and I look at if I just watch the videos and I had the date covered up of when it was turned in, I could probably predict when it was turned in based on the quality of the video, because the top videos that I see, the ones that get A's, are generally turned in early by people because they're not rushing to get it done at the last minute before it's due. At 11:50 on the night it's due, they're not like, oh, I got to get this turned in the next 9 minutes. Like, they've already done it in a way that wasn't panicked and stressed out and compromising their work because they need to get it in on time. So, do yourself a favor. This has a big, big effect on your grade. Try to do a good job with it. Get ahead of it. Don't see it as, well, I have until this date at this time to get it completed. Get it done a day early, right? Sometimes things happen. Sometimes things happen that are beyond your control, right? We lost power at my house for a short period yesterday, right? But many of us know that that's sort of a new reality in this valley, is that power outages happen from time to time. Some people had their power shut off because of the wind, right? We had a temporary power down because I think a tree limb fell on something. So they got us restored, but without power, well, I'm probably not going to be able to turn anything in during that power outage. So, and since you've had weeks to turn stuff in, saying, well, my power was down at, I lost power 5 minutes before the due date isn't really a good excuse. It's kind of like, well, I didn't have gas in my car to drive to the final. Well, you got to prepare for stuff. Don't be doing stuff at the last seconds. It's a bad idea, right? So plan ahead. Try to get this done. Try to finish it at least 24 hours early. That way, if something does go wrong, like a power outage, or you all of a sudden realize like you weren't as prepared as you thought, or now you have a question about how to do it, or the way in which you were going to make your video now all of a sudden isn't working the way you thought it was going to work, well, you still have 24 hours to fix all that, and you don't have to go into panic mode where the quality of work really does decline. So, work on it ahead of time. Start working on it over Thanksgiving. Start piecing it together. Start planning it and thinking about what you're going to do. Turn it in a few days early. Those are usually the ones that get A's a lot of times. Like the really good quality work. I can tell the person wasn't rushed. They weren't trying to just go down a checklist and look at the minimums that they had to do and go, well, I have a confidence interval in there somewhere, and I have a hypothesis test in there somewhere. Like they've thought it out. That, the same thing that I've been talking about this whole semester, which is you create a narrative, you create a story about your data, and then you support it with evidence. The people who do that, and it's obvious to me they know what they're talking about, they get an A on the project. As you deviate from that, where you're just reporting numbers and reading numbers off a page and you don't have much conclusions and maybe your graphs aren't labeled very well, those are all things where you start getting deductions. And those are also the things that I see more of for projects that are turned in the last minutes or even hours of the due date, right? So just a suggestion, just in general, it's a good idea. Right? Same thing with essays. When you're writing an essay in the English class, if you're trying to write the thing the night that it's due, it's probably not going to be very good. It just isn't, right? You want to write a good essay. What do? You got to write your rough draft a few days ahead of time, walk away from it a day, come back the next day, look at it and reread it and go, oh God, this seemed really good when I wrote it, but now that I'm reading it, I realize it's not very good at all. And then you edit it. And then you leave it and you come back the next day and go, okay, it's better, but I still see some things I can fix, right? If you do it that same night, you're biased by your own work. You haven't had a little bit of space to really look at your work and come back with fresh eyes and go, oh, this wasn't as good as I thought. That's the whole point of a rough draft, right? Is that you've taken your first attempt at it and it seemed good that night, but it's probably really not very good. And you can talk to writers about this and they'll tell you, right? I mean, there's a famous quote, I forget which writer said it, but he was talking to writers and he said, writing is rewriting. Like everyone thinks, I'm reading this book and this person just sat down and wrote this book. No, they didn't. They wrote the book and then they rewrote it and then they rewrote it and they rewrote it and rewrote it and rewrote it. And then eventually you ended up with a good quality book, right? But it takes lots of rewriting in order to make something good. It's especially true with essays that we all write since we're not professional writers. It takes us more time, and it's the same thing with a project, right? You want to do a bunch of work on it, and then don't check it off the list and go, okay, I took care of confidence intervals yesterday. I don't have to look at them again. Treat it like a rough draft. Yes, I did confidence intervals yesterday. I'm going to look at them again and see what I think. Now that I have fresh eyes, since I've walked away from it for 24 hours, let me look at them again. And you're going to find things that are bad. You're going to look and go, oh my gosh, on my scatter plot, I didn't label things. He's going to mark me down for that. And then you can fix it. You're going to go, actually, maybe I can change the way this histogram is done. I'm looking at it now and I'm thinking maybe I should play around with the bin size a little bit. And then you change the bin size and you're like, oh my gosh, this looks so much better, right? All those little things you want to make sure you're trying to do, and you want to make sure you're giving yourself some fresh eyes to come back and do it later. I can generally tell a project that was thrown together in one evening versus a project where the person went back to it a few times and really put an honest, genuine effort into it, and the grades reflect that, right? Because the quality is very different. So if you have questions about how to do different components, please come to office hours. Again, today is a weird day. I've got my dog in and out of the vet. I've got appointments, it's windy, of course. We could lose power at any time. So it's just a weird day for my office hours. I will have some of my office hours, but I kind of, today is weird. So I have to be a little bit flexible. But my office hours for the rest of the semester should be pretty much when they're supposed to be. And like I say, if you're sitting there and you're like, well, I work during his office hours, so I can never talk to him, send me a message and we'll try to set something up so that you and I can talk and I can answer your questions for you, because it's really important that you do things well on this project, because this project will move your grade, right? Okay. So, and the short thing, make sure you see by November 30th, you need to get some confidence intervals done, right? Using this part about confidence intervals there. And, good idea, this putting it together, which procedure do I use? It's a great idea. It's kind of an ongoing topic in statistics right now. It's kind of a bit of a controversy that's going on about confidence intervals versus hypothesis tests. Some journals have said no hypothesis tests. If you submit work to our journal to publish, needs to be confidence intervals. And then other things outside of statistics, like psychology and stuff, they've had to get harsh in the way that they accept statistics for psychology and stuff like that, because it turned out that a lot of people were either they didn't understand the statistics very well, or they were just, the truth is, when you publish papers, it's to your benefit. It builds your name, your brand, right? As a researcher, the more papers you have that do well or say interesting things, the more you've built your brand, and you're likely to get a tenure position somewhere and stuff like that. So some people, may be tempted to use less than ethical, less than rigorous work when they're trying to publish things. And so there's been some controversies in the last few years about that. So it's actually fairly interesting. Which procedure do I use? And then in the real world, when you might end up in a situation where, your job or the area where you're doing research or your company wants you to do a little bit of statistics or whatever, says, yeah, no hypothesis tests, confidence intervals only. And then that decision is made for you. But in the project, I should be seeing both, right? Because I want to know that you understand both of those things. Okay. With that said, let's dive into some stuff. Okay, where were we? So we were talking about confidence intervals, and we're going to get into now. Oops. I always forget the PDF pages in the chapter index are always off a little bit. Let's see. I think it's up here, 390. Here we go. So, hold on. All this running around this morning, I realized I haven't had any water, and I'm starting to get the hiccups. Give me 1 minute. Okay, thank you for your patience. So, hypothesis testing, I would say, is probably the most complicated thing to actually understand in this entire class. And it's one of those things where you can take sort of a shortcut and just kind of memorize how to conduct a hypothesis test. And that's actually important because you have to know how to make StatCrunch run your hypothesis tests for you. But I want to stress this because it's going to come down to part of the grading for the project is what you should not do is just run a hypothesis test in StatCrunch and then read the hypothesis test to me, right? Where you say, okay, I did the hypothesis test. This is my p-value, so we rejected the null, or whatever your conclusion is. You need to give me more than that. If that's all you're doing, then it's like a problem out of the book or something. Like it's not, you haven't really done stats because StatCrunch was the one who ran the hypothesis test, not you, right? What you need to do is make sense of that hypothesis test and give me a conclusion, give me an interpretation. What does it mean? Like tell me in the terms of your survey questions, what does it mean that the hypothesis test told you to reject the null or to fail to reject the null, right? And the wording for these, you really got to get right. It is very easy to use the wrong wording for a hypothesis test. I see it all the time in these final projects or just when people are learning it. It's very easy to think you're saying the same thing. Like in, when we talk to each other in everyday life, English is a very rich language and that there are lots of different ways to say the same thing, right? I mean, you see this when you're writing an essay. The teacher says, okay, you read this paper. Don't just repeat it word for word. You have to interpret it into your own words. So it's still the same information, but you're putting it into a new set of words, right? So there's this tendency to want to do that with hypothesis tests and say, well, I'm just going to say the same thing, but in a different way. The problem is when you're so new at hypothesis tests, you don't see that what you're saying is different and in fact wrong, okay? I know sometimes with math teachers, there's this tendency where students are like, oh, why are you making me say it the same way? I'm saying the same thing. I'm just saying it differently. The difference is we, as ones who are very good with math, know that what you're saying isn't the same thing and it is in fact wrong. So that's what you have to be careful of. So people who say things like, well, the p-value was high, so we accepted the null. That's actually, when you're brand new at hypothesis tests, that's a very reasonable thing to think makes sense. But in fact, it does not. So you want to make sure you're being very careful about the wording you use and then making your conclusion, your interpretation from that, but doing it in a way where, there's just a couple little things you have to navigate. And unfortunately, if you use your words incorrectly, it's just wrong, right? I know it may seem like, well, he's overreacting, but you'll see this when you're doing the homework. If you state it wrong, it is just a wrong statement, right? And you'll start to understand this as you deal more with hypothesis tests. You'll go, oh, I get why this was a big deal that I couldn't say that I accept the null because that's not what a hypothesis test does. But it takes a little while for that stuff to sink in. And this is part of the reason that we're covering it now, even though we have a few weeks left of the course. Why am I starting the last chapter now? Because if I just give it to you and then we have 3 days until you have everything due, you're not going to have enough time to sit with hypothesis testing and really understand the subtleties of what's going on, because there's a lot of things that come into this. There's a lot of probability behind the scenes in a hypothesis test. You're just going to have StatCrunch spit out a p-value for you, which is a probability, and then you're going to interpret it. But behind the scenes, there's a lot of probabilities going on, and you have to understand what that probability really means, right? It's very easy to just go, okay, StatCrunch, calculate my hypothesis test, there's a p-value, okay, and you don't really put much thought into what that p-value is really representing, but that's kind of the whole point, right? That's what you need to do. So what I'm saying will make more sense, and I'll have to repeat some of this as we go through this because, like I say, I really have to – there's a lot of subtleties. There's a lot of nuance in a hypothesis test that you want to understand. It's kind of like – well, and like I said, there's probability in a hypothesis test. Probability is a tricky thing for people when they first start learning it, right? It's like you have your basics of probability and you're like, okay, that's pretty easy. And then pretty quickly we get into challenging problems. right? Because you can take a problem, and if you change one or two words in it, all of a sudden the meaning of that problem is different. It's, there's a lot of subtlety in probabilities. It's the same thing with hypothesis testing. There's a lot of nuances you have to get comfortable with. All right, so let's get some definitions out of the way. In statistics, a hypothesis is a claim or statement about a property or population. Let's make that a little bigger still. How about that? So basically your hypothesis is just, remember, we study samples, but we want to make statements about populations. That's the whole thing about statistics, is I want to be able to say something about a whole group of people or whatever. It doesn't have to be people. I want to make a statement about a whole entire group of things, but I'm going to do it by studying a small subset of that group of things, right? So if I want to say something about the entire VC student population, I'm not going to go ask all 10,000 students a question. I'm going to ask 100 students a question or 200 students a question. And then if I do that right, I should be able to expand that statement to the whole population. So that's what a hypothesis is. It's a statement about a property of a population. Okay. So it's similar to what many of you learned about at some point in grade school. You learned about a hypothesis for science. This is a little different, but it's the same basic idea. You have an idea about, in this case, a population, and you want to make a statement about it, right? Either a proportion or a mean or whatever, but you want to make a statement about a whole group. Okay. A hypothesis test is a procedure for testing a claim about a property of a population. So we may want to say something, we may want to make a statement, and a cursory, like just a shallow cursory viewing of the data, you may say, well, yeah, that's look at the data. It supports what I'm saying, but maybe not, right? There's a lot of considerations that we've looked at in the numbers that we've done. So you have to run a hypothesis test and really say, is the claim that I want to make, is it valid, and is it supported by the data that we have, or is what I'm looking at possibly just random sampling error, right? I always go back to, and I think it really helps ground people, you have to realize that when we run multiple samples, you're going to get slightly different measurements each time. Right? So let's say that one day I sent one of you out to go ask about how many people on campus support the vaccine mandate, and one of you came back with a proportion of 0.79. And then the next day I send one of you out to do the exact same thing, and you come back with a proportion of 0.82. Well, can I make the claim that the number of people who support the vaccine mandate went up in that one day? It sounds like it, right? Well, one day we measured 0.79, and the next day we measured 0.82. So isn't that evidence that the proportion of people who support the vaccine mandate increased in that 24 hours? And the answer is no. That's not good enough. It could just be that random sampling error. I could send two of you out at the exact same time to measure the proportion of students who support a vaccine mandate, and at the exact same time, one of you might get 0.79 and 0.82. So you have to be really careful that your interpretations in the statistics are in fact what the data supports. So you go, okay, well then what do we do? Well, what we do is we run a hypothesis test. You could make a hypothesis that says, we think that the proportion of students who support a vaccine mandate is larger than it was yesterday. That could be our hypothesis that we're testing. And then our p-value comes back really, really low, and we go, oh, I guess I got to reject that hypothesis. I guess it was wrong, right? So it's hard. You can't just always look at the numbers directly and then make your conclusion. You have to think about things like, well, there's some drift when you do multiple samples. Is that what I'm measuring? Is just the sampling drift, or was there an actual change in the population itself? It's a little harder to measure. Okay. So here's some examples. Medical researchers claim that when people with colds are treated with echinacea, the treatment has no effect. Well, that's going to be kind of a, that's a big statement. So you have to make a hypothesis test. You have to make a hypothesis. We think that people who take echinacea to treat a cold have no better outcomes than people who don't take echinacea, right? And then you would take your data, you would construct a hypothesis test, and then you would see, right? Quality control for companies, mean weights, right? You might measure flight to flight and say, well, it looks like people on this flight are heavier. So it looks, and that how much people weigh is a big deal on planes, because the more cargo you have, the more gas they have to buy, and that's expensive. So, they have to design seats so they can cram you in as tight as they can into those planes. So you have to, the airlines care very much about the average weight of an individual, right? Because they would like it if we all weighed like 5 pounds, so they could just stick many of us on a plane, and it wouldn't take very much gas, and they could sort of move things along. But they might want to know, is it true that people are heavier than they were 20 years ago? Because if so, they're probably going to have to make some adjustments to the seats and stuff like that, right? Yeah, and it even says here the thing that I've been saying. When conducting hypothesis tests as described in this chapter, instead of jumping directly to procedures and calculations, be sure to consider the context of the data, the source of the data, and the sampling method used to obtain the sample data. This is not something that you can get through by just memorizing what buttons to push in StatCrunch. You do need to know that to conduct a hypothesis test, but if you think that's the whole thing, then your hypothesis test is going to be sort of low quality in your project, right? So here's the idea. Here's our basic concept of hypothesis testing. So here's our idea. Rare event rule for inferential statistics. If under a given assumption, the probability of a particular observed event is extremely small, we conclude that the assumption is probably not correct. So here's what you're going to have. You're going to have a bunch of things that you know are true, and then you're going to have one assumption, the hypothesis. Okay, so your hypothesis is the thing you don't really know. You're like, I think this is true, but I don't really know if it's true. It looks like it's true from the numbers, but maybe not. Maybe I don't know. Maybe I'm not reading the numbers well enough. And so then what we do is we construct a confidence or a hypothesis test around that hypothesis, and then the hypothesis test will calculate a probability for us. We call this the p-value. The p-value is going to tell us the probability of things occurring in the manner in which we said that it happened. Okay? You do this every day. When people talk to you and you decide if you believe that person or not, you're calculating what is the probability that this happened the way that this person said it did. Now, you're not doing it in a scientific way. You're kind of going from a gut feeling type of thing. But it really comes down to what is the probability that you believe this person, right? So, for instance, like this morning, I wasn't late, but I could have easily been late if things had slowed me down when I dropped my dog off at the vet trying to get home. What if I was 5 minutes late, and I come in and I say, sorry, I'm a couple minutes late, everybody. I had to drop my dog off at the vet this morning, and I had to do it at a certain time, and then I had to try to get home, and I was just 5 minutes late. Most of you are probably going to go, oh, yeah, that sounds reasonable. It's a lot of people own dogs, and if you own a dog, you're probably taking your animal to the vet on occasion. That seems reasonable. Okay, I probably believe what he's saying. But if I had said, okay, everyone, sorry, I'm a couple minutes late because a bunch of clowns broke into my house, and then they dragged me away in their little clown car, and then they took me somewhere, and then I was, some aliens abducted me, and then they were running tests on me, and then they got me back a little bit late. Are those things possible? Yeah. it's possible those things occurred. Is it probable? No. Like each one of those things, clowns busted into my house, that's pretty unlikely. Then they took me away in their clown car, that's even less probable. And then you're talking about aliens. The probability of that event is so low that no one in the class would believe me. None of you would believe that that's what occurred, because the p-value, the probability of that occurring, is so incredibly small that you're going to go, what? He's just making this up, right? So in some sense, the hypothesis test is intuitive in that we're calculating a probability, and if that probability is too low, we say something's wrong here. Something's not right. Like the probability of this occurring in the way that we saw it is so incredibly low, I don't believe it. In some sense, we do that every day. Now, the mechanics and understanding how the hypothesis test works is much more complicated than that, but that's the basic fundamental of a hypothesis test. What is the probability that things occurred under the way we think it did? And since the hypothesis test is built on a bunch of facts and one assumption, then if something doesn't feel right, what's the only thing that can be wrong? It's your assumption. The assumption that you made, you go, well, these facts aren't wrong because those are facts, right? We live in a world where facts are sort of, people just choose their own facts that you want to believe or not. But in statistics, and the way you really should do this in general, is facts are facts. If there's facts out there, you can't just ignore them and say, I don't like these facts, I'm going to pretend that they don't exist this way. In statistics, we don't get to do that. The facts are the facts. If something's wrong, then it must be your assumption. It must be your hypothesis that is wrong. Okay. But notice like here's a subtlety. Here's one of those first subtleties. A high probability does not give evidence that what I said is true. So, like if I say, yeah, sorry everyone, I was a couple minutes late this morning because I had to go to the vet and I had to drop my dog off and then get home in time. Most of you would probably go, yeah, there's a high probability that what he's saying is true. But that doesn't mean I'm telling the truth. It just means that it's a very believable story. It could have been that I went to the grocery store, but I wanted to tell you that I went to the vet. So I came up with a probable story, but I mean, I really did go to the vet. But see, what I'm saying is I could have gone to the grocery store. Just because what I'm saying is probable doesn't mean that's what really happened. And this is one of those subtle things that you want to be careful about in the hypothesis test is a hypothesis test never proves that your hypothesis is correct. And that sounds so bizarre to people. Like, isn't that the whole point? Is that we're trying to prove that my hypothesis is correct? And in fact, the answer is no. A hypothesis having a high probability does not mean that the thing is true. It just means we didn't find evidence to not believe it, right? I could come up with a ton of different really believable stories and just feed you any one of them. That doesn't mean that I'm telling the truth. But if I tell you something that, yep, there were clowns that busted into my house, they took me away in their car, then there were aliens that abducted me, like that one, to reject that. Like we have evidence that like that's so unlikely we're going to reject. So be careful, because when we run a hypothesis test, even when you're trying to prove something, you're still looking to reject your original hypothesis. So you have to be very careful about how you choose your original hypothesis, because your ultimate goal is to reject the original hypothesis. So what you want then is to not make your original hypothesis the thing you want to prove. You make your original hypothesis the thing you want to reject. And that is a very weird idea for some people. So let's go a little further now that I've explained some stuff. Where is the thing I'm looking for? Okay, here we go. Two important things. We actually have two hypotheses in every hypothesis test. There are two of them. One is called the null hypothesis, and one is called the alternative hypothesis. Okay? The null hypothesis is generally like the boring thing. It's the thing that has already been accepted. If you're trying to make some kind of a claim that is interesting or new, then you should make that the alternative hypothesis. Never make the thing you're trying to prove the null hypothesis, because the null hypothesis cannot be proven correct. All we can do is reject the null hypothesis. If we fail to reject the null hypothesis, that is not evidence that our situation is correct. But rejecting the null hypothesis is evidence that our situation is incorrect. So you have to kind of play this game of, how do I prove the statement incorrect so that I end up proving the statement I want correct? That's why we have two hypothesis tests, right? So for instance, let's just say that, let's go back to the smoking ban. Let's just say that for 5 years in a row, we measured the support among students for a full tobacco ban, and we measured that it's right around 0.8, that's the proportion. Well, and then maybe we think this year, I think things have changed. I think maybe that number is even higher than it used to be. Well, our null hypothesis should be that it's still the old boring thing that's been shown time and time again, that the proportion is 0.8. Right? That would be my null hypothesis. And oftentimes we use this notation of H sub 0. So H sub 0 means my null hypothesis. Okay, what is this? H sub 0, what is that, a semicolon? P equals 0.5. What does that mean? Well, it has to be in context. So you have to know from the problem you're working on, what does the proportion mean? But if we're following this example of students who support a tobacco ban, then we would write H sub 0 semicolon P equals 0.8, because that would be like the example I'm giving of 80% of students support it, right? So that would be our null hypothesis. It's usually like the boring thing. And notice here they say, I want to read this sentence because this is how you want to think about this. We test the null hypothesis directly in the sense that we assume or pretend it is true. So you pretend the assumption is true, and then you find a probability based on that. So we assume the assumption is true and reach a conclusion to either reject it or fail to reject it. So think about that language, because that's very specific language. Notice we did not say you either reject the null hypothesis or you accept the null hypothesis. That's not how these work. You either reject it or you fail to reject it. So that's what I'm getting at, in that you never really support your null hypothesis. You only reject it or don't reject it, right? Just like this morning, I think most people probably believe, which is the truth, but people believe, well, he was almost late because he took his dog to the vet. That doesn't mean I really took my dog to the vet. It just means you believe me, right? So a high probability of it being true was not evidence that I was telling the truth. However, if the p-value is really low, that is evidence that I'm lying, right? So that's that real subtlety that takes a little while to get used to. So then what we would do if we think that, well, I actually think now this year the true proportion of students who support a tobacco ban is more like 0.85, then that would be our alternative hypothesis. Okay, that's where we stick the thing that we actually want to prove. You stick it in the alternative. Okay, you put it in there. So this is either denoted by H sub 1, right? The original one was H sub 0. The null, or the alternative, is either H sub 1 or sometimes H sub A. I forget off the top of my head what they use in our homework, but it'll be obvious, which it should be clear. And then it'll walk you through like some details about hypothesis testing. But if you, like on your projects, if you're trying to prove that something is you want evidence for a conclusion that you want to make, using a hypothesis test, then the thing that you want to support should be your alternative. Never make the thing you want to support be the null, or your best case scenario is it will be inconclusive. Inconclusive is not good evidence. So you don't want your best case scenario to be inconclusive. Okay. Right. 4 minutes. Right, and so this is what I'm talking about, but they've got it in words right here. So note about forming your own claims and hypothesis. If you are conducting a study and want to use a hypothesis test to support your claim, the claim must be worded so that it becomes the alternative hypothesis, right? You can never support a claim that some parameter is equal to some specified value. So In other words, it's usually greater than or less than. So my alternative hypothesis test for what we're doing would be that H sub 1 of P is greater than 0.8, right? My alternative hypothesis cannot be that P equals 0.85. That's what I ultimately think it is, but that can't be my alternative hypothesis, because the alternative hypothesis has to be whatever the leftover is when you reject the null. So if our null is that it's, like, do you see what I'm saying? If our null hypothesis is that the P is 0.8 and my alternative hypothesis is that it is 0.85, well, what if it's not either one of those? Right? What if it's not either case? If we say that it's, my null hypothesis is that it's 0.8, and then we see that it's more likely bigger than that, then we can say, well, it's bigger than 0.8, right? That's kind of the claim we can make. It's bigger than 0.8, and we have evidence that it's close to 0.85, right? That's a pretty good case that's pretty convincing that it's probably bigger than it used to be, that the proportion has grown. But we can't just say, well, my null is 0.8 and my alternative is 0.85, because there's lots of other possibilities that are not encompassed in those two outcomes. Okay, that's why they're saying here, generally you don't have an alternative hypothesis that says your P is equal to a specific value, because that's not how the probabilities work. Okay, and it looks like, let's see. We'll start with this example next time. We'll start with this example 3 and kind of work through it. So let's see. It looks like today's Monday, so we do meet again on Wednesday. Ventura College generally has Wednesday, I believe, right? Yeah, we do have school on Wednesday. We only get the holiday for Thursday. So we will have class on Wednesday, and then you can start thinking about your hypothesis over your Thanksgiving break and work on them then. Okay? Anyone who wants to hop into Zoom, hop over, ask me questions, anything related to the class. Let's talk about it, and we'll go from there. Otherwise, thanks, everybody. I'll see you in a